Hello, we are Senior Design Team 12 presenting the Independent Valve Control Project designed by Evan U. Savage, Justin LaBarge, Sawyer Rehack, and Carson Bath. The overall goal of the project was to design and build a standalone mechanical system to provide independent valve control on the SAE supermileage engine. We want to do this because currently the engine has a traditional internal combustion camshaft, which due to the fixed profile is not optimized for all RPMs, and we can achieve benefits by replacing it. Using an independent system, we'd be able to implement other valve technologies like lift valve and duration. With the power source from a battery, because of no rotating mass, we would be able to improve engine efficiency overall.
So to the right here is a mock-up of our final CAD design of the final system. So the components of the system are mounted to the supermileage engine head via an ABS 3D printed housing. There are two 90-degree aluminum rockers used to change the force direction from the voice coils to the valves themselves. Steel rods are used to provide the rocker rotation. Each rocker features a pin and slot assembly to allow the voice coils to push and pull on the valves. And then finally, heat sinks and fans were added to the voice coils to aid in heat transfer. So here's a little diagram of how the final system actuates the valves. So as I said before, the 90-degree rockers take the horizontal force from the voice coils and translate that into a vertical force on the valves.
All right, and in order to verify that our system would survive its stress environment, we performed some structural analysis. This was generally done with finite element analysis, which was then verified through hand calculations. The system was analyzed with a max force of 55 newtons, which is what we calculated would be required to meet the max engine speed. We also assumed the valves would be stuck, as this would be the worst case highest stress situation. You can see here a summary of the table of our different simulations. The lowest factor of safety being for the contact stress. The rest of the simulations showed much higher factors of safety, which would appear that these are over-designed. However, the dimensions were limited from this contact stress as well as other geometric constraints based on mounting it to the engine itself. A harmonic analysis was also done to check for natural frequencies, as well as heat transfer analysis to make sure that the system would not get too hot.
So all the specifications that were defined by the supermileage team were verified. Due to the high actuation speed of the voice coil motors, we were able to actuate the valves at the high RPMs of 7,000. We also added under 5 pounds to the supermileage vehicle, and the power usage was below 4.8 watt hours. Additionally, our system is able to implement all of the valve technologies that were wanted. Soon, the supermileage team will finish implementation and the build of our design. And we do consider this project overall to be a success. The design that we produced is able to increase engine efficiency through the implementation of all the valve technologies. The project also increased the team's understanding of the design process and the inner workings of an engine, as the project required that we know circuits, programming, heat transfer, strength materials, machine design, and FEA.